Hi everyone, this is part 2 video for the surface water budget estimation using satellite remote sensed hydrometeorological data. In this second video, I would like to demonstrate how to pre-process the datasets for surface water budget estimation in QGIS. So I've just launched the QGIS with blank map. Actually, I used this QGIS version of very recent version of QGIS. Now the long-term repository recent version would be 3.16.6. So I just installed and opened this QGIS blank map. So after that, I will open this load map from this XYZ tiles. So if you drag on this blank map, you can see this kind of the roadmap provided by the QGIS. After that, I will open the layer with this Open Data Source Manager. So if you click this one, and then please click this vector things, then you need to press this browse button to find the data. So actually you need to go to the data Uganda folder, and then this Uganda folder would be the shapefile. Okay, so included this kind of shapefile, so you need to click this .shp file. So click and add, close. After that, you can see this Uganda shapefile just added on this map. So right click to have zoom to layer, like this one. Okay. So after that, another right click to see the properties. So here you need to go to this symbology tab. After that, I will this simple fill click, and then I will use this transparent fill, apply, and then this stroke color would be the blue and stroke width with just 1. Okay, so apply, OK, and then you can see this kind of the region of the Uganda country map. Okay, so at this point, please go to your data folder for data Uganda. On here, you can find these two precipitation data with the TIF file. So at this point, I will change the name of this file. This is too long, so I will use this imerge December 18 and FEV February 19 TIF. This would be the first file, and second would be wet season. For this one would be June to August 19. So like this one. So you need to change your file name like this one. This would be dry season, and this would be wet season for the precipitation. Okay, so after that, I will open these changed precipitation data with Open Data Source Manager. In this case, I will click this last tab. Then you need to find your data. Just change the name, dry, just open, add, and another one, wet season, add, close. So you can safely add this precipitation data on this Uganda country map. Okay, so now I will change map symbology for this precipitation data. The first one, I will click properties, And then on this symbology tab, you need to click this single band pseudo color. And then open this color ramp with all color lamps. And then red, yellow, blue color you need to click. Then click this equal interval and classes would be 10. Also, I will just use this minimum and maximum color lamp value. So this one would be 0 and 1500. I will use just after that I will apply OK. And then you can see this different color map with the symbology and another one property, all the same work. So it already, so 10 classes for equal interval and minimum 0 and apply OK. So I just changed this map symbology with the different color. So I will move this Uganda map on here. So as you can see, this color lamp would be equal. So you can see this. If you see this wet season, more precipitation would be around all the Uganda countries. But if you click this dry season, yeah, around the 0, not much the precipitation on this map you can find. Okay, so now I will add another data set for the evapotranspiration. So I will use this open data source manager, go to rest tab, and then you need to find the ET dry folder first, and then you can select with the shift button all these data, modis data, and add and close. So you can see these all the associated the dry season modis data just added on this QGIS map. But in this case, you can see some very high values you can find on here. All the data on this MODIS for ET data. So it need to reclassify with 0 values for the kind of garbage data. I will make 0 with the some tool in this QGIS application. So please go to this processing tab and click this toolbox. And then I will use reclassify tool. So RE reclassify. So on here you can see the reclassify values range tool. So if you click this one, you can see this kind of the reclassify values range, the tool. So I just selected this very recently added the data on here. So I will show you why I need to change this kind of values as a 0. So I will use this garbage value minimum would be 32760 and maximum value would be 32767, and for new value would be 0, and operator would be more than equal to 0 for range. And I just show you how to changes with this kind of tool. So I don't need to save this file, but I will just click run, and then you can see this tool would be executed. So please wait some minutes, some seconds, and then you can see this newly added reclassified grid. So in here you can see very higher values just changed as 0 on here. So you can see this evapotranspiration amount more clearly on here. So you can compare this data with the newly added map for evapotranspiration. So I need to process all the same work for all this kind of the ET data. So I will close this layer with remove, and then I will again click this reclassify value range tool, double click, and I will use this run as batch processes to click. So here I will select the data from open layers. So if you click that one, you can find the new window box with this kind of the opened map. So I should remove, uncheck all the precipitation data, but only the ET associated, dry season associated layers on here. So click OK. And then you can select this kind of multiple data set on here. So also the minimum value that I already showed you would be 32760. On here you can see if you click this auto fill and then click this fill down, and then you can automatically fill this one. And another maximum value would be 32767. Again, auto fill down, and this would be 0. Fill down, and operation would be this one, and fill down. So I just click all these kind of things and then leave as a default the other. But in this case, you need to save this kind of processed data with the new name. So I will use the name of this processed data would be MOD16 ET. First file name would be 2018. Julian day would be 329. So save. And then you can find this autofill setting, this autofill mode. I will use fill with the numbers. Click OK. And then you can see this number would be added. So I will change all this Julian date with the actual my comparing with my file name. So you need to change all this name with the right Julian day. So this one, and then so you can also change if you need the different numbers, you can do by your preference, but I will just keep the original file Julian date on here. So another one would be 17, 25, 33, 41. Remains 2 data. So 49. And this would be raster data. So 2019. Julian day would be 057. Okay. So I all the changes these numbers with the Julian date with the exactly same with the original file, and then I will select this load layers on completion. So I will load all these changed the layer with the different range on this QGIS platform, and then click run. So this might take some minutes to get all the file you wanted. So you can see the process toolbar. So it takes some minutes again. All the getting this kind of the processed data on this QGIS map. Okay. So meanwhile, you can see your data folder for the ET data drive. You can see this kind of processed data. You can also find. Okay. So almost done with this kind of job with the reclassify values for the ET data. So you need to wait some minutes all the completion of this process. So I just completed all the process. After that you can see all this new layer with the new ranges for the ET data. So this was the batch process we just made this kind of new map. Okay. So now I will make a summation map for this processed ET data. For that I will use this last tab, last calculator. And then you can see the opened layer on here. But I will use this processed data to make summation. So plus, so you need to all the summation to make a seasonal map for the dry season. Okay. So this should be 8 days data, but I need a seasonal map for that to calculate what balance for that. Okay, so after that I need to save this data Uganda folder with the modis et December, January, February 2019. So save, and then you can click OK. This one. So now I have this newly added data, but I don't need this kind of all the processed data layer. So I will click with Shift all this data and remove this layer. Okay. And then you can see this newly added dry season evapotranspiration map. Okay. Also, you need one more last calculator execution with the scale factor. Actually, this modis ET data need to consider the scale factor with 0.1 because you need to consider millimeter. So actually, this kind of the modis ET data required to adjust with this 0.1 with the scale factor. Okay, so on here I will just final ET data for this one with the ETDJF19. Then I will click OK. So this would be scale factor added the data for the ET. So I will remove this layer as well. So on here you can see this precipitation data as well as just dry season ET data. Okay. So at this point I will add wet season ET data as well. So find this ET wet folder and then shift this file, add and close this one, and then I will do the same job with the liquid spy values. So I will make batch process and then layers. So this one should be unchecked. So all this wet season, the modis data, I would like to consider. So the first, the minimum value would be 32760. So autofill 32767, autofill 0, fill down, and then operator would be this one, fill down, and so I will change this wet season. The name of mode is 16 ET. The Julian date would be 19. This one 145. So you need to fill with the numbers. After that, you need to change all this Julian date with the actual the Julian days. So I will change all of these Julian date with 8 days evapotranspiration. It might be tedious job, but you should do to make this kind of seasonal map. And then 201, 209. This one and almost done. 225 and 233. And last one 241. So after that, check this load layer on completion and run. Also, it takes some minutes for the completion of all these required data processing. Okay. So now the process would be almost done. So you need to wait the last one to be processed. So okay, I got all the completion of these data. So I will close and then you can see all the newly added this kind of wet season modis 16 ET data. So again, you need to open this last calculator and then go to make this summation map with this all the processed data. So I will add all these one. So last one. Okay, so I will save this one with modis et June, July, August. This one. Then save. Click OK. So I just added this one with the completion of this tool. Again, I will remove all these ET data. But in this case, I will show you the data property with this modis data. So if you open this property and information tab, you can see this unit would be just millimeters per 8 days, but you can see the scale factor would be 0.1. So you need to consider this scale factor to make actual evapotranspiration map. So again, I will select this one with Shift to remove this layer from the map. Okay. After that, one more last calculator to consider scale factor, and then also I will click this one, but in this case just name ETJJA19, save, click OK. So this would be just added, so I don't need this previous one, remove layer. Okay. So again, I will change map symbology for this ET data. So go to properties and then go to symbology tab, single band pursuer. So in this case, all color lamps and yellow green. After that, equal interval with 10 classes. And in this case, I will use the maximum number would be 800. Apply. And go to transparency. And I will use another transparency with the zero values. We just change it from the water body and other associated. It doesn't require the ET map. Okay. So apply. Okay. And then you can see this kind of different the map symbology for that, for the wet season, and another transparency, the dry season for the pseudo color. It already selected equal interval with 10. And I will change 800 to compare these two wet and dry season map. Okay, so I've just added these to the map. So this would be wet season map, and this one would be dry season map. So you can see the different evapotranspiration, the spatial map. So maybe this wet season more evapotranspiration because of the precipitation amount. Okay, so we just added this precipitation amount as well for the wet season, and this wet season the evapotranspiration map you can see. So we will check the water balance after getting the other data also added. Okay, so I will move this Uganda data layer on here. Okay. So now I will go to the data folder for the data Uganda. On here, you can find this TWS folder. This would be GRACE follow mission data for the terrestrial water storage. So on here, I will change this long name for the GRACE would be GRFO TWS with December 18. Actually, I required this March data as well. So GLFO TWS MAL 19. Also, I need June data GLFO TWS, and then this one should be JUN June 19. And last one would be, this would be September data GLFO TWS SEP 19. Actually, I will calculate the differences from this March to December to March would be dry season, and June to September for the wet season. So this should be considered as the changes during the dry and wet season. So I will go to this one, this calculation. I will go to Open Data Source Manager. Then last tab, you need to select this TWS folder, and then firstly open this December data, add, and then March data, because I will make some calculation for these two data's differences. If you zoom to layer one of these data, you can see this would be world global data. Then again, I will back to zoom to layer for the Uganda layer. So I will clip with considering this Uganda, the layer extent. Okay, so on here, I would like to see the properties of this GRACE F4 data information. So in here, you can see all this data details. Actually, this would be just used their unit with meters. So it need to consider 1000 if we need to consider millimeter based computation. Okay, so I will go to this last calculator, open. So I will calculate these two data differences. So I will make this one with March data first, and then minus December data for the GRACE, and multiply by 1000. You need to consider millimeter, meter to millimeter with this 1000, and then output layer would be DT WS December, January, February 19. So save. So after that, you need to check this Uganda layer extent. So it already selected on this map, so you need to just click OK. After that, you need to remove these two data. Remove layer, and then if you move to this Uganda layer on here, you need to find these data differences from the dry season. Okay, now I will open another data set for this GRACE for the wet season. So on here, I will firstly open this June data, add, and then another one, September data. I will make another differences for these two data. So again, open, click this Uganda first, open last calculator, and then I will calculate these two differences for September minus June. You need to consider 1000 to consider the millimeters. Okay, after that I will use this one. June, July, August 19 TIF I will use, and then save, so you don't need to change this one. So click OK, and then you can find this calculated the differences. Again, go to move to this Uganda layer on here, and then you don't need to disgrace data, so remove this one. So actually I made these two differences for the dry season and wet season for these Uganda areas. Okay, again I will change these properties to see the symbology. So on here I will click this single band pursuit color, and then in this case I will choose all color lamps and lead blue, this one, and then I will click this equal interval with 10, and minimum would be, I will consider these data ranges to compare all these the differences, so I will use minus 116.60, and this one would be 180. Okay, so click apply. OK, and then I just changed this symbology, and another one I will also change it the same way. Pursue the color, and this one, this should be, and 118.80, so apply. OK, so I made these two different symbology from my calculation for this one. So actually if you will see this legend, so this would be the wet season, so you can see more the added the wetness you can find on here. But this the dry season, you can see all the minus wetness you can find as well. So far I just made this all these different data set from the precipitation with the iMerge dry season, iMerge wet season. So this would be precipitation, and this evapotranspiration dry season and evapotranspiration wet season, and this dry season for groundwater or terrestrial water storage, and also this one we can also estimate some groundwater things with the terrestrial water storage for the wet season. Okay, in this video I have made demonstrations of the dataset preprocessing jobs for surface water budget estimation in QGIS. And I will continue to estimate the seasonal surface water budget component in the next video. Thank you for watching.